Have you ever stopped to think about how researchers actually measure things you can't see or touch? The big stuff. It's honestly one of the biggest hurdles in data analysis. And today, we're going to dive into the tool that was literally designed to solve that exact problem. I mean, think about it. How do you put a ruler to something like brand loyalty or weigh job satisfaction? It's impossible, right? These are incredibly important ideas that drive almost everything we do, but they're abstract. They're invisible. So how on earth do you build a reliable scientific model around something you can't even directly observe? See, the problem is that our usual statistical tools, like a simple linear regression, they often just fall flat. Yeah, they're great for simple one-to-one relationships, but they really struggle with the messy, tangled-up reality of how people think and feel and act. You end up with this huge gap between the neat little models we build and the complex world they're supposed to explain. So to bridge that gap, you've got to take a totally different approach. You have to start thinking like an architect, but instead of designing a building, you're drafting a model for an invisible concept. You need a blueprint for the unseen. And just imagine for a second, what if you had a tool that was like a digital drafting table, but for your theories? A place where you could just sketch out these complex ideas visually, test them, and tweak them until they're perfect, all without having to write a single line of code. Well, that tool actually exists. It's called IBM SPSS Amos, and it's basically the go-to toolkit for any researcher or analyst who needs to build models of our complex human world. So let's pop the hood and see what makes it so powerful. Okay, so Amos is built on this really powerful methodology called structural equation modeling, or just SEM for short. You can think of it as a framework that was designed specifically for this one massive challenge: testing the connections between the data we can measure and the powerful hidden concepts that we can't. And this quote just nails it perfectly. While all those standard methods kind of get stuck, SEM, and by extension Amos, gives us the bridge we need. It connects all the tangible dots of our data to reveal the big invisible picture. So how does it actually work? Well, this is where Amos really shines, because it's all about its visual approach. You don't program a model, you literally draw your theory. Instead of getting totally bogged down in complicated code like you might in other programs like R or M+, Amos just gives you a digital canvas. And this is a total game changer. It means you can actually focus on the theory and the ideas behind your model, not just the programming. You get to watch your hypothesis take shape right there in front of you. The whole visual language starts with something called observed variables, and they show up as rectangles. Just think of these as your building materials, the concrete, measurable data points you've actually collected. Things like age, income, or how many times somebody clicked on an ad. And here's the other half of the puzzle: the latent variables. These are represented by ovals, and these are the big, abstract ideas at the very heart of your blueprint. Concepts like brand image or quality that you're trying to measure indirectly by using all that observed data. So building your model becomes this super intuitive three-step process. Seriously, that's it. First, you draw your main ideas as ovals. Second, you link those ovals to the real data you've collected, your rectangles. And third, you just draw arrows to show how you think all these concepts influence each other. And boom, that's it. You've just drawn your hypothesis. But of course, a blueprint is just a plan, right? The really crucial next step is to test its structural integrity. You have to find out if your beautiful design actually holds up when you throw real-world data at it. This is pretty much the moment of truth for any researcher. You've got your theory all visualized, but now you have to ask the hard questions. Is it actually a good theory? Does the evidence from my data really fit the model I just drew? This is where we get into something called model fit. And to figure that out, Amos gives you a set of key statistics that you can basically think of as a model report card. You're just looking for good grades on a few key metrics, like CMIN/DF, CFI, and RMSEA. If these numbers fall into those ideal ranges, that's a really strong sign that your blueprint is a solid match for reality. Now, what if the fit isn't great at first? Well, Amos can actually suggest improvements. It uses something called modification indices, which are basically tips on which connections in your model might be missing or wrong. But, and this is a huge but, a good architect never just guesses. Any change you make has to be backed up by solid theory. That way you know your model is explaining reality, not just random noise in your data. So, once you've built a solid blueprint that fits your data well, what happens next? How does architecting these invisible models actually help us make real-world decisions? Well, let's look at some really powerful examples. In marketing, you could build a model that shows you exactly how much brand image actually drives purchase intent. In healthcare, maybe you can uncover some hidden factor, a mediator, that's the real key to improving a patient's well-being. Or in HR, you could finally prove how improving your company's internal service quality directly leads to higher profits. These aren't just guesses, they're testable, actionable models. And this right here is the ultimate value. Amos lets you move past just describing what's in your data. It gives you the power to actually test and confirm a theory. It seriously elevates the scientific rigor of your work, whether you're doing it for a PhD dissertation or a presentation to the board of directors. At the end of the day, mastering a tool like Amos says a lot about you. It signals that, yeah, you've got the technical chops to handle complex data, but more importantly, it shows you have the theoretical depth to ask big, meaningful questions and build models that truly explain how the world works. So, when you think about it, your data is telling a story. It's a story about how the world works, full of hidden drivers and invisible forces. The only real question left is, are you ready to be the architect and reveal its structure?